So, hi, Amy, how are you doing?
Hi, sir. I'm good, thank you. How are you?
Good, good. So, last time you remember we did binomial theorem extension and we looked into the how to use the binomial terms. Uh,
hmm
that's kind of tricky. Did you understand all the concepts which we talked about?
Not really. Some of them were quite tricky, like you said, since it's my year 13 stuff. So I think I just need a bit more practice.
Sure. So, this is your year 12. Next year, they'll be more relevant. And I thought when we are on this topic of binomial theorem, why not cover it all, right? That's the whole concept. And since I could realize last time that there was some difficulties in few questions, so I've revised my material and I'll provide you today more steps so that we can easily understand all those concepts and then we'll go through them. And I
hmm
hope that'll be very easy for you. In case of any difficulty, just stop me and then, ask your questions so that, you really understand all the concepts, correct? So
Okay.
let me begin by sharing the screen with you. Okay, so here is your new lesson on binomial theorem. We are going to talk about general terms. And as you can see right on the top, we have extended it to A plus level. So we'll take a few examples which will deal with first three terms, that is to expand a binomial and get the first three terms. And we'll also determine how to find a given specific term number. We'll find coefficients and the index. We'll also work with product of two binomials, one of them with an expansion. And then we'll have a general concept about how to work with such questions. We'll also focus on the middle term. In many binomial expansions, you may have sometimes one middle term, sometimes two middle terms, right? So if you have a odd degree, in that case, there will be even number of terms. Even number of terms means there are two numbers in the center. So we say two middle terms, okay? Uh, we'll take up examples where we'll try to find how to get remainder of the whole thing. And we'll also work with some shortcut methods to find the coefficient of a trinomial. Now here I've specifically written a particular formula which says middle term of 1 plus x to the power of 2n is 1 times 3 times 5 times so. Some is a product of odd numbers over n factorial times 2 to the power of n x to the power of n. This is a complicated formula but very important from examination point of view. We'll actually derive this particular formula also, right? Here's a quick review. A plus b to the power of n, as you see, this is the expansion you have been working with. N choose 0. In general, we know that n choose r is equals to n choose n minus r because these binomial coefficients are symmetric. The value of n choose 0 is same as the value of n choose n. And as we move inwards, all have same values. They're symmetry. General term, TR plus 1. We write specifically R plus 1 because we want to correlate all our examples with N choose R, right? As you
hmm
can see here, the very first term has 0 as R value, right? But it is the first term, right?
Right. Yeah.
0. So 0 plus 1 gives me the first term there, and R value will be 0. That is how we have correlated it. And as you know, the R plus 1 will be n choose R, a to the power of n minus R, b to the power of R. So the exponent of b is same as R value, and the exponent of a, the first term, is n minus R. We'll actually also see when this equation is modified, the value of a is placed as 1. In that case, it's a much simpler series to work with. We do take a lot of advantage of this simple series to solve many questions, right? Even if a is not 1, you could do one thing very clearly, and that is you can take a common, right? So if you take a common, factor it out,
Um,
then you get 1
mhm.
plus b over n. Do you understand?
Right.
1
Yeah.
over b over n. And so a is 1. You can write this series in a very simple form, just as with the b exponents, right? Increasing order. Now that
hmm
is a very important series to work with. And in this increasing order series, you will notice that if the value of b is very small, then higher terms can be neglected. And we can work with the first few to approximate the result.
Oh,
Like
okay.
how to do it.
Yeah.
Right? Okay. So let's take a example. Now, we'll begin with the very first example, which is find the binomial expression from the first three terms. Okay. So basically, the question here is the first three terms of the expansion ax plus b over x to the power of 6, where a is greater than 0, in descending powers of x are, we are given the polynomial. This is the polynomial which represents first three terms of our binomial expansion, right? 729x to the power of 6 minus 2916 x to the power of 4 plus cx squared. Find the value of a, b, and c. So it's like working in the reverse order. You're already given the expansion and the
Mhm.
simplified terms, first three, and you to find the value of A, B, and C. Well, the case is very clear. You just expand the binomial, right, which you know, just expand this. And once you have done so, you can relate term by term, right? First term, second term, right? Their coefficients rather. You can connect the coefficients and get the result. Now, the strategy here is we simply write what is 630, so we get the terms in terms of A, B, and C, right? So we straight away get the terms, calculate the value of NCR and put it there. So we get, you can see AX plus B over X to the power of 6 is A to the power of 6, X to the power of 6 plus 6 times A to the power of 5, BX to the power of 4 plus 15 times, which is the value of 6C2 a to the power of 4 b square x squared. Now, first three terms are given to us right there. So we can equate 1 to 1. So clearly, a to the power of 6 can be equated with 729. And so once we do that, a to the power of 6 is 729. Sixth root of 729 gives us the value of a. So that is so simple. We find the value of a as 3. Perfect.
Mhm.
Now, we can take the second value, which is negative 2916, and equate it to the coefficient of x to the power of 4, which is for us 6a to the power of 5 times b. We already know that the value of a is 3. So substituting 3 in this particular equation, we can isolate b and get its value. And the value of b comes out to be minus 2. Correct?
Mhm.
So we have value of A and B. Now it is time to compare the third term, which is C is equals to 15 A to the power of 4B squared. Substituting the value of A and B there, we get the value of C also, which in this case is 4860. So this is a
Mhm.
very common test example, and it normally comes in the test paper. You'll always find such a question, right?
All right.
So all the steps are clear to you, Amy, on this?
Yeah. So just find one of the letters, and then you use them to find the others.
Perfect. And begin from the very first one because the first one has only a constant, right? So you
Right.
find
Yeah.
68 and start from there. Now, example 2. Ascending powers of binomial expansion. Find the first four terms of binomial expansion 2 minus x to the power of 6. Now, see, here what I've done here is purposely taken 2 outside the bracket. Do you see that part?
Yeah.
Factored out 2 so that I get 1 minus x over 2. Do you see that? So
Mhm.
now I get that term 1 plus or minus b, right? Now when I expand this, I'll get ascending powers of x, correct? Since the questions require also
Oh.
getting ascending powers, I have done that part and very easily. 2 to the power of 6 has been factored outside, and now I'm actually expanding 1 minus x over 2 to the power of 6. Do you see how simple it is as compared to
Mm.
the previous case? Right?
Yeah.
Okay, straight away. And you get very simple terms NC0, NC1, NC2, NC3 with higher and higher powers of minus x over 2, right? So minus
Mhm.
x over 2, minus x over 2 square, cube, and so on. Since you need four terms, we'll go up to cube. Perfect. NC3, correct? That will give us four terms. So
Mhm.
now it is very simple. Knowing the value of, we know n is 6 for us. n is 6 for us. Substituting 6 there, we can calculate the values. And as you know, NCR can also be calculated by, for example, NC3, which is, let me write down separately. We have written here 6C3 will be what? Will be 6 times 5 times 4, right? Multiply 3 terms and divide by 1 times 2 times 3. So
Yeah.
easy. So using this, we calculated the values, and we have the first three, x to the power of 3, the first 4 terms. Perfect. Simplify this. 2 to the power of 6 is outside. Once you have simplified it, then you can just multiply with 2 to the power of 6, which is 64, right? Just multiply each and every term by 64 and write down your answer as we got it right there. You see that part. So you'll find that factoring out A is very beneficial, and it avoids big numbers. At the end, multiply by that factor and get all your bigger numbers. You get the idea, right?
Yeah, yeah.
Work with simpler numbers. That's the
Yeah.
whole. Perfect.
Yeah, makes sense.
Yeah. Now, next example here is working with term numbers. The question here is, determine the fifth term in the expansion of this. So what is going to be the fifth term? Tell me, what will be the NCR value and how do we go about?
So the R value would be 4 because we did
Perfect.
R plus 1.
Perfect. You know, n value is 10 already, so there is nothing left in this question. R value is 4 for us, so we know T, 4 plus 1, which is the fifth term, will be 10C4, and the terms are A is x squared, B is minus 1 over x. Substitute these two and calculate. If the calculator is not allowed, then this method is very good, right?
Yeah.
10C4 means 10, 9, 8, 7, 1, 2, 3, 4. Cancel out most of the terms and get your answer. And we get 210 x to the power of 8 as our answer. Clear?
Yeah.
Example number 4, coefficient of terms in the expansion. So find the coefficient of x to the power of minus 4 in this particular expansion, right? So ax minus 1 over bx squared. So since we are looking for x to the power of minus 4, let's find a general term. In the general term, we'll just equate the index with minus 4 and find what the n value or r value should be, right? We'll figure out r value. N is known to us as 11, right? So again, tr plus 1. General term will be 11cr because 11 is the exponent. First term is ax to the power of 11 minus r. Second term is minus 1 over bx squared to the power of r. Now, see the simplification here. 11cr is your coefficient. A to the power of 11 minus r, which is a constant. I separated x out and wrote x as x to the power of 11 minus r, right? Open this bracket. And in the second bracket, we have minus 1 over b to the power of r and x to the power of 2r minus, right? X is in the denominator, x squared. So x squared in the denominator to the power of r gives you x to the power of minus 2r, correct? Is this? Now you can combine the x terms, which is we have 11 minus r minus 2r. So we have 11 minus r minus 2r. We want that to be minus 4, correct? So we equate minus 4 with 11 minus 3r, which is minus r and minus 2r. And when you solve that, you get r value as 5. Once you know r, then you can always calculate the coefficient, correct? Substitute the value 5 for r in your expression, right? Everywhere 11 minus 5 and b to the power of 5 with the negative sign. So you get negative answer. So we have negative minus 462. So you get minus 462 a to the power of 6 over b to the power of 5 as your answer, correct? So that is how you're going to do this type of question. Now let's take example number 5, which is find coefficient with products. So this time, just slightly different question. We will be expanding 5x minus 1 to the power of 6 and then multiplying by x minus 3 to solve this particular question. So Amy, can you please read the question?
Yes. So what? Just to find the coefficient part. Okay. Find the coefficient of x to the power of 5 in the expansion of x minus 3 times 5x minus 1 whole thing to the power of
Or
6.
6. How will you do it? Tell me.
Okay, so I think I would start by expanding the 5x minus 1 whole
Perfect.
thing to the 6.
Yes.
And then you only need to do it because they're asking for x to the power of 5. You don't
Correct.
have to do all the way till x, or like to a constant. You just need to do up to, let's say, x to the power of 4 maybe.
Maybe, yeah, 4. Because we have x here, right? So that will give you the fifth power. Perfect. X to the power of 4.
Okay.
That
Yeah.
is correct. Yes.
And then, yeah, just find the pairs that give x to the power of 5.
That is perfect. So we should start with a series which is in descending order, right? So we started with, of course, 5x is the first term. So we have a series in descending order of powers of x. So the first term will be 5x to the power of 6. We are just expanding now this portion, which is the binomial portion to the power of 6. So when you expand this, you get 5x to the power of 6, 6c1, 5x to the power of 5. The other term is minus 1, right? And then 6c2, 5x to the power of 4 minus 1 whole square. Now, since, as Amy was saying, we need not go further. We only need x to the power of 5. When you multiply by a constant 3, then the term which will give you x to the power of 5 is the one shown as 5x to the power of 5, correct? So when you multiply these two terms, minus 3 and the second term, you will get x to the power of 5. And when you multiply x with the third term, you'll again get x to the power of 5. Now, both those terms add the coefficients because they're the like terms, right? So add their coefficients as shown here and then get your answer. So that is as simple as that. So important thing here is only expand as much required, right? You don't have to really do the full expansion, right?
Right.
Example 6. Find the remainder if 6 to the power 53 plus 8 to the power 53 is divided by 49. This is a very difficult question, Amy, and we have seen sometimes in the examination. So the trick involved here is we could write both 6 and 8 as 7 plus or minus 1. And then that gives you two different series, one with a plus b, one with a minus b. And when you combine these series, half of the terms cancel away, right? And then you get whatever remains, twice those numbers remain. And that helps us to find the answer. And we'll also understand few more strategies while solving this question. So this question is very important in overall understanding of binomial theorem and its expansion, right? That's why we have taken it here. Now, see, 6 has been written as 7 minus 1, and 8 has been written as 1 plus 7. You could write 7 plus 1 also to the power of 53. Now, what I did was that I actually swapped 1 and x. So it is minus, and the degree is 53. So minus 1 to the power of 53 will be negative, right? So therefore, when I swapped, I mean, I wrote 1 minus x instead of 7 minus 1, because 6 is 7 minus 1, correct? So I took minus outside because now power is 53. So minus 1 to the power of odd number will be negative, right? The other term, 7 plus 1 or 1 plus 7, I wrote in terms of 1 plus 7 to the power of 53. Now, both the series we will write with the increasing powers of 7, right? Because I've taken 7 later. So both will be written in increasing powers of 7. Now, here is the expansion. I dropped minus, but I just wrote 1 minus 7 to the power of 53. So as you can see, the minus 7 powers are increasing. Do you see that? And we have NCR in general, correct?
Can I just ask a question?
Yes.
So you put the minus at the front because you want to cancel it out?
Later, yes.
Oh, right, okay.
Later. So individually, what I'm doing here is I'm expanding only the 1 minus 7 and 1 plus 7 terms.
Right.
So 1 minus 7, when you expand, you get that negative 7, negative 7 squared. So there are even and odd powers. Wherever there is an odd power, you get negative sign. That means alternating negative and positive sign. But important to note here is that the last term is negative, correct? Because 53 is your power. So the last term is negative. Perfect?
Yeah.
When you expand 1 plus 7 to the power 53, all the terms are positive, correct?
Oh.
All the terms are positive. Now, what we're trying to do is We are trying to do A minus B, right? So at this stage, rather, we'll take away, we'll put minus here now, right? So that means we'll subtract this. So when you subtract this, negative becomes positive. Do you see that? So
Yeah.
we get plus 53, 73. They add up. But the other terms cancel. Do you see that? The other terms cancel because you're taking away this equation
Oh.
1 from this equation 2. So we are doing 2 minus 1. 2 minus 1. Is that okay? So when you do 2 minus 1, this plus and this minus becomes plus and plus twice. So we
Yeah.
have this 2 outside. Is that clear to you?
Wait, so where did the 2 come from?
Because we have 2 of these, right? All the numbers which were negative, they became positive and they added on. So you get
Oh,
twice.
right.
All the numbers which were positive, they cancelled away, right? So for example, the first term itself, these are positive. When you take away one from the other, they cancel.
Yeah, yeah,
That
okay.
constant, they cancel. Do you see that part?
Yeah.
And what remains is the odd powers, right?
For
When you,
2 of them.
right? Odd powers, and they have become twice, and so we get this part in inside. Is that clear to you?
All right, okay. Yeah.
And we are doing 6 to the power of 53 plus 1 over 7, which is 8 to the power of 53. Correct? Now you got all the series. Now let's move forward. You have 7 also inside common factor, so we can factor out 7. So that is the next step. I factored out 7. So leaving 53 as your first term and making all of the powers as even powers of 7. Do you notice this now? So now we have even powers of 7, right?
Oh, because you took a 7 out. Yeah.
Yes. We took the 7 out. Even powers of 7 means like it is a 7 square something, correct? And what
Yeah.
is 7 square? 7 square is 49.
49.
Since everything here is from here to here has even powers of 7, all of them are multiples of 49, correct? When you add them up, you get some number which will be a multiple of 49. Clear?
Right, yeah.
So what we have here is 49 times some natural number, right? That's what I've written in short, because we are only interested in figuring out when divided, what is the remainder. Now this part is completely divisible, leaving 0 as your remainder. Perfect?
Yeah.
So the remainder will come only from this term, which is 2 times 7 times 53. That is going to give us remainder. So now let us divide 2 times 7 times 53 by 49 and check what the remainder is. And when you divide, you get 7 as your remainder. 15 goes, it goes 15 times. 7 is the remainder when you divide by 49. And therefore, the answer will be that the remainder is going to be 7 when you divide this number by 49. Is that clear to you?
How come you don't, wait, so add the 2 times 7 and then brackets 53 plus 49n.
Yeah.
How come you don't like do, so what you did with the remainder, you did 14 times 53.
Yes.
But how come you didn't do 14 times 49n?
Because when you divide 49, it will go completely, right? So even if you do it, you get a 0 remainder because that number 2 times 7 times 49n, when you
is a
divide
multiple
by
of
49, the 49 cancels. You get a whole number, right?
Yeah.
So 0 remainder. Do you see that?
Mm-hmm.
So that is
So it's
why
only 2 times 7 times 53 that will give a remainder. Okay, got it.
that's why I wrote that is a 49 times some other integer when you multiply by 2 and 7. This is a multiple of 49 and therefore no remainder. So that is what we do. But Emmy, you should also see one more thing here, which is sometimes students will simplify 7 over 49, write it as 1 over 7, and they may report 1 as the remainder. Well, 1 is the remainder when you divide by 7, not by 49. So don't simplify this part, okay?
Oh
So
my God. Yeah.
right? That's also...
Imagine doing all that working and then getting the answer wrong.
That is
Oh my
so
God.
perfect. So do
Yeah.
you get this concept now, how to do such questions?
Yeah, it's clear. It's long, but I get the concept. So if it comes again, I would know like where to start and like what to do.
Yes.
Yeah.
Perfect. And so instead of making it negative earlier, I chose to do 2 minus 1, right? We could always take two equations, subtract one from the
I
other
like that method.
to get the result, right? So that is how we'll do it. Now, Here is another very interesting question. We'll talk about rational terms. Now, as you know, square root of 2 is irrational, correct?
Mm-hmm.
However, square root of 2 square is rational because that is 2 only, right? This is equals to 2. 2 is a
Right.
number. So when we have square root and when we have even powers of square root, it becomes rational. You
Rational
understand?
terms.
So that is a concept to go about in the questions which we are now working with. The question is, find the number of rational terms in the expansion of square root of 7 plus fourth root of 3 to the power of 100. That is the question for us. So basically, in the expansion, we are looking for terms which will not have a square root type of things, but which will have even powers, and that should help us to get the answer, right? So in general, we can say that is our expansion. 100 is your n value, 100 CR, 100 choose R, and within brackets, square root 3. First term is, I should have written square root 7, not 3. Square root 7 to the power of 100 minus R, and the second term is fourth root of 3. Fourth root of 3 to the power of 3, right? So that is your second term. So just expand like this. So this is your expansion. 100 CR, 7 to the power of half, because square root 7, right?
All right.
To the power of 100 minus R. Here we have 3 to the power of 1/4. This is the 1/4 root to the power of R. So that means now it is 7 to the power of 100 minus R divided by 2. And here it is 3 to the power of R divided by 4, correct? Now, to make it rational, what should be the condition? Tell me.
Even terms. No, even exponents.
R value, see, R over 4. So R over 4, we want R to be 4 multiple, right? Multiple of 4.
Oh, because that would, yeah, because it would, so if it was 4, it would be to 1, and then
Yes.
anything of the multiple divide like completely, like a whole number, basically.
Whole number. So multiples of 4. Now, therefore, the possible values, they have to be between 0 and 100, since 100 is your exponent, right? So our values between 0 to 100, all multiples of 4 between 0 to 100 will include 0, 4, 8, 12, so on till 100. And how many terms do we get out of this?
So you do 100 divided by 4 being 25,
Yes.
and then you add the 0 being 26.
That is true. So 100 divided by 4, which is 25. So you get 1 plus 25 terms, which is 26 terms. So don't forget about 0. That is a valid exponent in this case. Perfect. So we clearly get 26 terms which are rational, which have rational coefficients. Clear?
Yeah.
Example 8. The middle term in odd degrees. So as I was saying, depending on the degree, we may have one middle term or two middle terms. So in this case, since we have taken odd degree, which is 9, there are going to be 10 terms, and therefore 2 middle terms are there. Now, those 2 middle terms will be 9 plus 1 divided by 2, which is the 5th term, and the next, which is 6th term. So 5th and 6th are your middle terms. So that is what I've done. The given expression has odd power, so there will be 2 middle terms because there are even number of terms. And these are n plus 1 divided by 2, and which is 9 in this case. 9 plus 1 divided by 2 plus 1, which is 5th and 6th are the 2 middle terms. So the idea is just to find 5th and 6th term, right? So T5, which will be T4 plus 1, so R value is 4. T6, which is 5 plus 1, R value is 5. Just evaluate those 2 terms and get your answer, right? So simplify and get those values. So it is so simple, but you should remember that if the degree is odd, we get 2 middle terms. Now here is a question, which is an application question. Can you please read the question, Amy?
So evaluate probability. Probability of selecting n persons from a group of 10 is modeled as 10 choose n, p to the power of n, 1 minus p to the power of 10 minus n, where p is the probability of any one person selected.
Perfect. Find the probability of, we have two conditions, three people selected when P is given to you as half, and nobody is selected when P is given to you as 0.7. Let me give you some concept here, Amy. Since this particular thing is very useful and probability is very close, we have to do this chapter soon. We're given probability of success, that means selection, right? So success is P for us, right? And failure, probability is always 1. If success is P, the failure will be 1 minus
1 minus P.
So that is why you have these two terms. Good to understand how do we get this particular equation, right? So P is the success and 1 minus P is the failure. So when we are saying that from 10, we have to get n successes, right? N successes. That means that success probability is to the power of n, but how many unsuccess? 1 minus P is Q value to the power of 10 minus n. So that is a very simple and a very practical formula to be used. And we call this binomial distribution. So we have only two conditions, whether there is a success or a failure, whether you are chosen or you're not chosen, correct?
Right.
So in all those cases, this formula can work. You see that? So that's a very good formula. It's a very standard one. So we are taking 10 people and n successes. In our example A, 3 people selected means n equals to 3, right? Probability given to us as 50-50, right? Both P and Q are 50-50. Substitute these values, correct? And just calculate the answer. You get 15 over 128 in this particular case as the answer. Now, many times you may be required to round it to 3 significant figures. Then use your calculator, divide, round it to 3 significant figures. Okay?
Yeah.
The second example is nobody selected, means n is 0 now. And P value is given to us as 0.7, right? Substitute 0.7 here. And now, again, calculate the answer. This is a very small number, right? Probability is high and you're not selecting anyone. So expect very high means a very low probability, 10 to the power of minus 6 we are getting, right? So sometimes you may be required to write answers in standard form. So remember, this is the answer in standard form, 5.9 into 10 to the power of minus 6, correct? If required in 3 significant figures, you could also write this, but there'll be a lot of zeros in between, right? A lot of zeros, you can count the zeros and then write 5.9. Is that clear to you?
Yeah.
Probably 5.9, depending on what the other number is, we'll just go with 590 at present. Is that clear to you?
Wait, so
yeah.
Did you say that was a very small probability?
Yes, very small, because 10 to the power minus 6.
Yeah, but so no one selected when the probability is 0.7, but that's quite high.
Yeah, a probability is high of selecting and you are not selecting anyone. That means like it was like a very rare case. You get the idea, right?
Oh, so the chance of selecting no one, it was so
very
like
low,
close to
very
0.7.
low. Yes, it's like you'll definitely select someone, man, because the probability is more than 50%. That's the whole thing, right?
Okay, yeah.
And you will not select is very low chances. That's what.
Yeah.
So when you go for an interview, for example, if you're going for an interview and there are 10 people and the probability of your selection is 0.7, that means most probably you'll be selected. I mean, you should do it like this, right?
Yeah.
So that is what the condition is saying. Okay.
Yeah. It's because logically you'd think that they're talking about if the probability is high, then the probability we get should be high. But actually, no, it should be really low because that means it's more likely to get chosen.
Yes, nobody is betting services. Nobody getting selecting means rare case.
Yeah.
Probably 10 to the power minus 6, correct?
Yeah.
Straight away, right?
Okay.
1 millionth. I mean, do you understand? 1 millionth is the chances of not selecting anyone. That's what we are saying, okay?
Right.
Next example. Now here, as I was saying, we have derived a formula for the middle term when we have x to the power of 1 plus x to the power of 2n, right? The question here is, show that the middle term for 1 plus x to the power of 2n is all this. And let's go through this derivation. It is working with the factorials and coefficients in a very efficient way. So we know that the general term can be written as 2n cn, right? When the exponent is 2n, and 1 to the power of 2n minus 1 because that is the 1. So we have a increasing power of x in our series, correct? X to the power of n. Now, the binomial coefficient, as you know, NCR, let me write down the formula here, as you know, NCR is basically equals to n factorial over r factorial times n minus r factorial, correct? So that is what the formula is. So we have chosen this particular expansion. So 2n on the top gives you 2n factorial in the numerator, and n here, 2n minus n is 2n minus n times n factorial, correct? X to the power of n. This is a general term, right? Now, what we have done here is we need to prove that this particular thing is what is given on the top. That is what we need to prove. So what we've done, 2n minus n is also n, correct? 2n minus n is also n. So we get n factorial times n factorial in the denominator. If you compare, n factorial we need, but the other n factorial we do not need. So this is how we are seeing. How do we cancel that n factorial to get the answer?
So we need to get an n factorial on the numerator
to cancel it out, right? We have 2n factorial, but not n factorial. So now see the strategy of converting that 2n factorial into something times n factorial. You understand?
Okay. Yeah.
So 2n factorial really means 2n times 2n minus 1 times 2n minus 2 till 1, right? The whole series.
Right.
Product of natural numbers from 1 to 2n. This is what it is. Now, what we have done from here is we split the series into even terms and in odd terms, right? Because see, 1, 2, 3, 4, 5, 1, 3, 5, 7, like this, and 2n minus 1 will be odd term, correct?
Right.
2 times n is an even term. So we are writing this series into even terms, which is 2n times 2n minus 2 up to 642, right? These are your even terms, I mean the numbers. And the other numbers are the odd numbers, 2n minus 1, 2n minus 3, 5, 3, 1. So we same numbers, we just put them into two different places. You're multiplying them all to get the complete sequence from 1 to 2n, correct? Okay. So we have, let us say this is our even series, right? And the other one is our odd series. But in all these terms will be from 2n to 1, all those multiples. Right. Perfect. So we have even and odd series. So definitely we have 1, 3, 5, 7. The odd series is matching now, correct? Do you see that part?
The odd series are matching.
This is what we want, right? Odd series.
Oh, yeah.
Correct. So odd series. Now we have to work with the even series. So in the even series, I can take 2 common from every term because they're even multiples of 2, right?
Right.
So these multiples of 2. So if I take from every term, these are n terms. From n terms, if I take 2 common, I get 2 to the power of n. You get the idea? Yeah. And inside half of these, so n times n minus 1 and so on. Half of 6 is 3, half of 4 is 2, half of 2 is 1. We get n factorial.
Oh, and then you can cancel
n factorial cancels now. Do you see that part?
Yeah.
I mean, this is an excellent exercise, and it really helps you to understand how to work with these binomial coefficients.
Yeah.
Simplify them in given situations. And once you cancel, you get your formula, which is required formula, and there you go. That is how you derive it.
So it's kind of like keep factoring until you get to the required what they are asking for.
That is true.
Okay.
Yes. Okay. And it shows some strategies also, how to rearrange your numbers, take factor 2 common from the even terms, and make the whole series as n factorial. Perfect. So almost at the end, last 2 questions to go about. Now here is a very interesting question. We had been always talking about finding the coefficient when we are given a binomial expansion. Now here, can you please read this question from here?
So find the coefficient of x to the power of 15, y to the power of 3, z squared in the expansion of x plus y plus a z to the power of 20 from the definition of NCR or n choose R.
Correct. So I'll explain you, this is also the beginning of the next chapter. So, and the end of this one. So I'll explain you the concept of n choose R. And then from there itself, will actually get the coefficient of a trinomial expansion. See how difficult the situation is.
Mm.
We had worked so difficult, I mean, so many steps for binomial expansions, correct? Now here,
Right.
we are looking for a coefficient of x to the power of 15, y to the power of 3, z square in the expansion of x plus y plus z to the power of 20, right? So I'm not taking any general term, nothing, but I'm going to use this definition of n choose r to get the answer. N choose R means x to the power of 15. Now we have to find the coefficient of x to the power of 15. That means n is 20. Do you see n is 20, right? So
Yeah.
from 20, I have to choose 20 really means there are 20 factors. If I expand this, it means we have 20 factors, correct?
Yeah. Oh, is it? Oh no, yeah.
Because it is to the power of 20. You'll multiply x plus y plus z times x plus y plus z times x plus y plus z 20 times. So you got
Yeah.
20 of these factors. Now from those 20 factors, we want x to the power of 15. So 15 we want x. Do you understand? 15 terms we want x to the power of 15. Do you see that? Now once you choose 15, you are left with only 5 factors. So from 5 factors, you want y to the power of 3. So you choose 3. Now, when you choose 3 out of 5, you're left with 2
Two.
factors, and from 2 factors, you
You
have
want
to choose
two.
z. You get your answer. This is the coefficient for x to the power of 15 times y to the power of 3 times z square. Nothing else is.
What?
Yes, you have answered the question.
Oh,
That is the power of n choose r. You see that?
yeah. Oh my God. So you can choose. You can use n choose r to find. But does it only work for trinomials?
Anything, no, any polynomial.
What?
Even for binomials, yes.
Even for binomials?
See, so now can you please read the result?
Coefficients of x to the power of a, y to b, z to the power of c, and then r to the power of d in the expansion of x plus y plus z plus so many terms until plus r to the power of n is n factorial over a factorial times b factorial times c factorial times d factorial, where a plus b plus c plus all terms plus d equals n.
Perfect. And this is when you find 20c, 20 choose 15 times 5 choose 3 times 2 choose 2, you will actually get what? You get 20 factorial over 15 factorial over 3 factorial over 2 factorial. That is your answer. You get the idea.
Oh,
So when you write, you know what n choose r is. You'll write 20 over 15 factorial times 5 factorial. Kind of simplify that, correct?
right.
So
Yeah,
at the
yeah.
end, you'll only get this result, which is simplified as shown here in this particular formula. It will be n factorial, which is 20 here, divided by a, b, c, d, all those terms, right? Which are the exponents, factorial. And you get your answer. So it is so easy. Do you see that part?
Mm. Oh my God. That's so cool. Like, so all the other methods of finding the coefficients, we still need them in
Yeah,
different
yeah.
circumstances, but
Definitely. We
this
still
is just like a help, like if you want to quickly verify something,
correct quickly.
this is the
And we have
go-to.
taken a simple case. It becomes slightly more complicated. Instead of x, I write 2x, 5y, or something like this. It becomes
Oh,
more
yeah,
complicated,
yeah.
right? We're not getting there, but you could still use the same method. And so here we have our answer. Just multiply them. Use your calculator to figure this out, and the numbers just before you. So it's the
Mm.
power of n choose r, which we are talking about.
Yeah, yeah.
Higher mathematics is so much dependent on this particular, coefficient. Beautiful.
Oh,
Yeah.
so does it come again in other topics then?
Yes, many other. I mean,
Oh,
calculus, for example, many Newton's methods are based on this. And
oh,
all the methods of approximation are based on binomial theorem, right? So when we took the series 1 plus x to the power of n, where x is
yeah.
lesser than 1, the whole thing, we have got so many names, McLaughlin, Taylor series, and this and that. You'll learn so many of these. All have this as the base, okay?
All right. Okay.
Last question here is another application of the same thing which we had been talking about. And can you please read this question?
Yes. So calculate exponents. After 5 years, the value of $1,000 invested at the rate of X% per year is modeled as A equals 1,000 times 1 plus X over 100 to the power of 5.
Yes.
A. Find the approximation for this expression in the form of A plus BX plus CX squared, where A, B, and C are the constants to be calculated.
Mm-hmm.
And B, estimate value of $1,000 invested at the rate of 6% per year after 5 years.
Correct. So you must have seen this formula, compound interest, and all those things, correct?
Yeah.
Many times, financial applications, huge. And calculation is not so easy. But see, as we had decided, the x percent, we are writing x over 100. So it is normally a value much lesser than 1, correct? 0.05 in this particular case when we say 5%.
Right.
We know that this term is less than 1, and therefore we can neglect the higher terms as correctly writing it in terms of a polynomial with just 3 terms, right? Because we're neglecting all the rest.
Yeah.
For accuracy, we may include 4th term also, because after, right? So in many cases, we may go for the 4th term also. I kept it simple, right? So, so we have this expansion using the binomial expansion. Again, 1,000 is already outside. We just kept it outside, and 1. And so we have an increasing power of x over 100, correct? Increasing powers of x over 100. So I didn't really consider the cubic function also. In your test examples, they will normally consider it because in money, it really matters, right? That's the whole concept. Okay. So when you expand, 1 divided by 100 is 0.01. And when you square 0.01, you get 0.0001. And when you cube it, it is like 1 millionth, right?
Right.
So it's a very small term, so we kind of neglect it. So anyway, we have a very simple expression to work with. As you can see, 1,000 plus 50x plus x squared is your simple polynomial, right, which is equivalent to 1,000 times 1 plus x over 100 to the power of 5. Do you see how simple it is?
Right, yeah.
Now,
so
yes.
You have to write afterwards like A equals 1,000, B equals 50.
Yeah, that now we know what A, B, C is. And we can write A is equals to, compare 1,000, B is equal to 50, and C is equal to 1 in this particular case, right? So now yes.
If you leave it like that and don't write A equals 1,000 and stuff, would you lose a mark?
Definitely. You lose a lot of marks. Because you're supposed to find that only.
Oh, but do you have it in the same form? So would they not give like method marks?
They will give marks, yes. So the question very clearly says, find the value of A, B, and C. Yes, you do have something which represents similar to your answer. I mean, similar to the situation, but you didn't explicitly write the answer. I have missed writing the answer. I'll definitely lose 1 mark here. At least 0.5. Yes.
Yeah, just one more thing. With the like first line, how come it goes 5C0 1 and then 2 and then 1? Or did you mean?
I'm sorry, typing error. Good job. I was just checking. I do many typing errors. Correct.
Yeah. Just in case there was another method, I was like, oh, have
No. I just copied 5C1 everywhere and then changed the numbers. And that time I was neglecting, so by that time I kind of just missed it. Good observation. I like it. Good. So now, see the second part, which is you have to really estimate what will this amount be after 5 years. How simple this is. Just plug in the interest rate. So if the interest rate is, let us say 6%, it could be anything. Just put 6 as the value, right? Because x is x%. So when you put that 6, you easily get your answer, which is fairly accurate. So we get for $1,000 be $1,336 at the end of 5 years. So the complete statement is required as an answer for a question. Okay. So that is how you're going to.
That's just like, what did you say? Did you say compound interest?
Yes.
Yeah, we used to do this. You do 1,000 times 1.06 to the power of 5.
Yes, same thing. We're talking about the same thing. And see how easy it is. We wrote it in a simple polynomial equation. And in that equation, put 6%, 7%, 1.5%, whatever you want to put. And you have your answer. You see how easy?
All right. Yeah. That's cool.
Yes. So in your notebook, you can make this equation up to the power of 3. It will be more accurate. and then apply to any situation, you will definitely get the answer.
All right. Okay.
So that is all about what I wanted to share with you today. Now, Amy, how do you find today's lesson? Did you understand it all?
Yeah, it's quite. I'm still a little bit surprised because you're saying it's year 13 stuff, and obviously I find it a little bit hard. But yesterday I found it like I was all over the place. But now actually I understand it like really clearly. Obviously I need practice, but like if I see now questions related to these kind of topics, at least I know where to start. I wouldn't be just like shocked and be like, what do I even do? So that's good. Yeah.
That's great. I was actually sure about it because when I went through yesterday's lesson, I knew the areas which needed more, preparation from my side, because it's my responsibility to teach you. So if I'm not getting it through, then something is wrong. So I took up these examples once again, and I'm glad that you understood today's lesson.
Yeah, I don't know how that happened because yesterday, because they're kind of like similar examples, but like I don't understand how I got it today. But yeah, I don't know, but it was really clear. So like I get it. Yeah. So stuff I learned was like I don't know, I wrote a few just points down. So like when expanding things like when it said decreasing power, only expand to what is required. So if it said x to the power of 5, don't go all the way to like the constant, because number one, you're time wasting, and number two, you don't need any of that. Factoring is a key. So when we were trying to get one of the like solutions into the same form that they asked for, kind of keep factoring out like we did with the n factorial and things, and try and like be aware of, so like we saw when we saw 2 n factorials at the bottom, but we only needed 1, we should be aware that 1 should be cancelled, obviously from the top, a numerator. So try and like be aware of that and then get it into that form so you can do so. And then rational terms, look for like even powers so that you can get rid of obviously the square root or cube root or anything. And I guess the last one would just be reading the question carefully, and like we saw with the last question, if they clearly state write the constants a, b, and c, do so. If they say round to 3 significant figures, do so. And like if they say write in standard form, do so.
Perfect. So, yeah. That's good. Excellent summarize. So with this, actually, we end this chapter. Amy, so you should be now in a position to answer almost all the questions from your book.
Oh, and I've done it.
Yeah, we're done with this, and we'll begin something new next time.
So no, I've done all the questions from my book. I couldn't know. Yeah, I know there was more than 70 or something. Honestly, I only didn't know how to do 4 of them. Okay. But that was because you said 2 of them were probability related.
Probability questions. Yeah, I told you the others, not to do. Yes.
Yeah, and the others now you covered in this lesson, so I can go back and do them.
So basically, I didn't want you to just substitute a value and calculate the answer. That's not the idea. When you're looking at the probability question, let's understand how at the first place they modeled it like this, right?
Yeah.
So once you understand that beauty of modeling, it is so simple and makes so much of sense. Then calculating those things. Perfect.
That's so true.
That's why I told you to wait for those questions. And now, just substitute a value and find the answer. Nothing more than that.
Yeah.
I'm glad you went through all this, and I hope you retain it till the next year and it'll be very, very bad.
Hopefully. I don't want to forget it. That would be really annoying. Yeah, at least we have these videos so I can refer back to it.
Yes, so I'll be uploading this video tomorrow. So have a good look at it. Yes, and do some more questions from my playlist now.
Yeah.
Right?
Because I don't have any questions in my book now. Because they're all like really...
from my playlist.
Okay, yeah, I will.
I'll share one with you, okay?
Cool. So, thank you so much,
bye for now, and all the best.
Thank you. I'll see you tomorrow. No, Thursday. Yeah.